Here, ready now for problem number 12. So this says find the exact values of the 6 trig functions of theta if theta is in standard position and p is on the terminal side. So basically, this is a point on like an XY graph. So 12 is X, -5 is Y. With these kinds of problems, it's so smart, almost essential, really, in my opinion, to go ahead and create the graph. 12, -5. So there's 12. There's -5. So what you do is you have this point here. And then you simply draw a line from the origin to that point. Now what's interesting about trig, what they're really wanting, really, it's this angle right here. That's the real angle. But the point is, the reference angle is right here. And the nice thing about trig is all the trig functions of this actual angle here is the same as the trig functions of the reference angle. So I don't have to work my problem trying to figure out this big angle here. I can simply go and find the trig functions of this angle, and it's actually going to be the same as that angle. So therefore, since I'm using this angle here, I, in a sense, can create a right triangle, and I know how to apply my trig functions to a right triangle. So if I have a right triangle here, this distance is 12, this distance is 5. If I use the Pythagorean formula, I can figure out the hypotenuse distance. So this is 144 plus 169, which is 13. So now this just simply becomes a problem of finding the trig functions for this right triangle. And of course, my angle is in the 4th quadrant. So after I find the numbers, then I need to attach the appropriate positive or negative sign. And I know I'm in the 4th quadrant. So if I go over here, the sign, opposite over hypotenuse. 5/13. And because I'm in the 4th quadrant, I know that the sign, which is like y, is negative in the 4th quadrant, -5/13, cosine. So ca, adjacent 12 over hypotenuse. And in the 4th quadrant, the cosine is positive. Tangent, toa, opposite over adjacent. And in the 4th quadrant, I know tangent is negative. Now, for the last 3 trig functions, I can just do my reciprocals. Cosecant, reciprocal of sine, so -13 over 5. Secant is reciprocal of cosine, so it's 13 over 12. Cotangent is reciprocal of tangent, -12 over 5. All right. Not too bad, hopefully. See what we have next. Number 13. Actually, 13 is just like number 12. So I'm not going to work it, obviously. Here the point is -7, -3. So your point's down here. Here's your right triangle. This would be 7. This would be 3. Figure out your hypotenuse. You're in the third quadrant. It's just what I did. 14. All right. These are some exercises and just figuring out which quadrant your angle is in. There are 4 actually problems here. Each of these problems, they give you 2 pieces of information. They're actually 2 trig functions. They're telling you whether they're positive or negative. For each of these trig functions individually, of course, there are 4 quadrants. Each trig function will reduce it down to 2 quadrants. But by having 2 trig functions, you simply figure out for each trig function what the possible quadrants are, and then you see what's in common. All right, let's just do it. That may not make a lot of sense. So for instance, cosine less than 0. In what quadrants is the cosine less than 0? Remember, cosine is like x. What quadrants is x negative? Well, x is negative in quadrants 2 and 3. So for this to be true, theta has to be in either quadrants. I just might write the numbers here, 2 or 3. But to say at the same time, the sine of theta is positive. Where is the sine of theta positive? The sine tracks y. Where is y positive? Quadrants 1 and 2. So both of these conditions have to be true. Well, if they both are true, then obviously theta has to be in quadrant 2 because the 2 is in common. So there's your answer, quadrant 2. So that's how you do all these. Sine theta less than 0. Sine theta negative. Where is it negative? 3 and 4. Cotangent of theta greater than 0. Cotangent has the same positive and negatives as tangent. So if I think of where's the tangent positive, tangent's positive in 1 and 3. Remember, we think of tangent as sine over cosine. For tangent to be positive, the sine and cosine have to be the same sign, either both positive or both negative. Well, that occurs in quadrant 1, they're both positive. In quadrant 3, they're both negative. So therefore, tangent is positive in 1 and 3. So what's in common here? Quadrant 3. Cosecant. Cosecant is just like sine. So in a sense, when it says cosecant negative, I can really think of where is the sine negative. The sine is negative in 3 and 4. Secant is just like cosine. So this is really saying where's the cosine positive? 1 and 4. What's in common? Quadrant 4. And finally, secant, which is the same as cosine. Where is the cosine negative? 2 and 3. Where is the tangent positive? 1 and 3. So what's in common? Quadrant 3. Now let me just check my answers, make sure I didn't confuse myself. Then that would, so quadrant 2, quadrant 3, quadrant 4, and quadrant 3. Yep. All right. Not too difficult, hopefully. So that was number 14. 15. Actually, another one of these. Actually, since they're so easy to do, maybe we'll just do them real quick. Where's the tangent positive? Tangent's positive in 1 and 3. Where's the cosine positive? 1 and 4, what's in common? 1. Secant, which is like cosine, where's the cosine negative? 2 and 3. Where's the tangent negative? 2 and 4, what's in common? Quadrant 2. Cosecant, which is like sine, where is the sine negative? 3 and 4. Cotangent is like tangent, where's the tangent negative? 2 and 4, what's in common? 4. Cosine negative, 2 and 3. Cosecant, which is like the sine negative, 3 and 4, what's in common? 3. And once again, I will just quickly check those. So quadrant 1, quadrant 2, quadrant 4, quadrant 3. All right. Now this 16 is just like I probably did a little bit ago. I think the, if you recall, it was, here I have the notes, it was problem 11, where they give us a trig function, and the key is they told us an acute angle, which told us the angle is in quadrant 1. So now we have the same kind of problem, where they give us a trig function, and then they tell us that the sine is positive. The reason why they give us this piece of information is, in knowing both these two things, we can figure out which quadrant theta is in. Where is the angle? And we have to know that because that's going to tell us whether the trig functions are positive or negative. Once again, this is like a two-part problem. We're first going to figure out the number for each trig function. And then as soon as we find the number, we go and figure out whether that number should be positive or negative. And that depends upon which quadrant we're in. So let's look. Tangent is negative. What quadrants can the tangent be negative? 2 and 4. Sine's positive. Which quadrants is the sine positive? 1 and 2. What's in common? 2. We know that this angle is in quadrant 2. So as we go and figure out the actual numbers of these trig functions, we can figure out the positive and negative by looking at the quadrant. So to find the numbers, I'm going to take this tangent function and recreate a right triangle based upon this. Of course, tangent, TOA, opposite over adjacent. So if I go over here and create a right triangle based upon this trig function. Now really, when I create the right triangle, I don't care that the tangent's a negative number. All I really care about when I create my triangle is just the actual numbers. So if this is my angle, opposite is 5, adjacent is 12, right? If I were to give you this triangle and say, find the tangent of theta, you would say tangent of theta is 5 over 12, which is what I have here. Now I need to find the hypotenuse. So I use Pythagorean formula, 5 squared plus 12 squared. That's like 169. So hypotenuse is 13. Now that I have a right triangle and I know all 3 sides, I can go find all my trig functions, and then knowing what quadrant they're in, I can then attach either a positive or negative. So for instance, sine is opposite over hypotenuse, so TOA, opposite over hypotenuse, 5 over 13. In quadrant 2, what is the sine? The sine's positive in quadrant 2. So cosine of theta, adjacent, 12 over hypotenuse, 12 over 13. What is the cosine in quadrant 2? Cosine is actually negative. Remember, cosine tracks x. X is negative in quadrant 2. Tangent, so-called TOA, opposite. You know what? I could do this, but they actually give me the tangent in the original problem. So now, the three remaining trig functions. Let's take the reciprocals. Cosecant is reciprocal of sine, 13 over 5. Secant is reciprocal of cosine. So you keep the negative. So it's a negative 13 over 12. And cotangent is reciprocal of tangent. And there you go. So once again, the key is, first thing you do is you figure out which quadrant your angle is in. Construct your right triangle. Once you have all the sides, do your trig functions, and then you go attach the positive and negatives from knowing which quadrant you're in. And I will check just to make sure. I hate to make a mistake and then confuse everybody in this video. And my answers look correct. All right, let's see what 17 is. 17 is just like the one we did. So let's just go through the first part. I'm not going to actually find all the trig functions. We'll just do the setup part of it. So sine, let's do the quadrant first. Sine is a negative. Where is the sine negative? Sine's negative in quadrants 3 and 4. Secant is positive, which really means cosine is positive. Where is cosine positive? In 1 and 4. So it looks like what's in common? Quadrant 4. This angle theta is in quadrant 4. Now I use my sine function. Sine is opposite over hypotenuse to create a right triangle. Opposite over hypotenuse. If I use Pythagorean formula to figure out this last side, it's going to be 13 squared minus 12 squared. 169 minus 144, 25. It looks like this is 5. So now you just go through all the trig functions, figure them out. In quadrant 4, figure out the positive and negatives, and you're good to go. All right. Let P be the point unit circle U that corresponds to T. Find the coordinates of P and the exact values of trig functions. All right, so basically, in a sense, T is like an angle. They're giving you an angle. And then what they're doing, I want to make sure, sometimes this is hard to read. Let me look at my other paper here. Okay. So just so you know, this copy, when it prints out, it should have printed out, it should have said P of X, Y is like this. Instead, it sort of separates the parentheses, so it looks a little, but what they're saying basically is, go find, here's your angle, 5 pi over 2. Go find that point on the unit circle and see what that point is. Let's do that first. That's part A. Go find that point. Well, where is 5 pi over 2? In terms of unit circle, 0's here, pi over 2, 3 pi over 2. But if you look at 5 pi over 2, I know 2 pi equals 4 pi over 2. So 4 pi over 2 is actually one trip around the unit circle, but I'm at 5 pi over 2, right? So really 5 pi over 2 is really 2 pi plus pi over 2. So I'm really up here at pi over 2. So I had to have a coterminal angle. 5 pi over 2 and pi over 2 are the same. Here's my unit circle. What is this point here? 0, 1, right? X is 0, Y is 1. So the point there on the unit circle is 0, 1. So basically, this is my angle. I had to go find this angle unit circle. Turns out this really isn't on the unit circle expressly, because 5 pi over 2 is really the same thing as pi over 2. So I'm up at pi over 2, the point is 0, 1, and then they go down and ask for all the trig functions. Well, the sine is the value of y, right? On the unit circle, whatever angle you're at, the sine is the value of y, which is 1. The cosine is the value of x, which is 0. The tangent is sine over cosine. You can think of as y over x. What is 1 over 0? It's not 0, it's undefined. Cosecant, I just take the reciprocal of the sine. The sine is 1, which is 1 over 1. You flip it, of course, you still get 1. Secant is reciprocal of the cosine. Since the cosine is 0, if I think of that as like 0 over 1 and I flip it over 0, what's that again? Undefined. Cotangent, it's 1 over 0. 0 over 1 is actually 0. So let me check those. So 0, 1, 1, 0, undefined, 1, undefined, 0. Here's the second one. This might be a little bit easier. Now they want you to go to the angle negative pi over 2 on the unit circle. Negative pi over 2 means you go pi over 2 in the clockwise direction. So if 0 is here, this is pi over 2, but if I'm thinking about negative angles, whoops, it's 3 pi over 2. 3 pi over 2 positive. In terms of a negative angle, it's negative pi over 2. So basically for this problem, I'm sitting down here. What are the coordinates of this point? 0, negative 1. So the point is 0, negative 1, and then I go do what I just did. The sine is the value of y, negative 1. Cosine's the x, 0. Tangent is the sine over the cosine, undefined. And if I keep going with this problem, cosecant, if you can see this there, cosecant is a reciprocal of the sine. So if you think of the sine as negative 1 over 1, the cosecant's 1 over negative 1, which is just negative 1. The secant is the reciprocal of the cosine. If you think of the cosine at 0 over 1, you have 1 over 0, which is undefined. And the cotangent is the reciprocal of the tangent, 0 over negative 1, which is 0. And I would just make sure I didn't get confused and mess anything up. All right. 19. Reference angles. All right. Remember, reference angles are, you look at the original angle, and then you find the shortest angle to the x-axis, either positive or negative x-axis. So let's just draw a couple of these. So first of all, let's go find 310. 0 is here, 180. 270. So in a sense, this is also 360. So it's like 40 degrees past this. So this whole thing is 310. This distance is 40. Now from here, to get to the x-axis, I can either go here or go here. Well, obviously, going here to the right is going to be shorter. And what's that distance? Well, hopefully you can see pretty easily it's 50 degrees. If it's 40 to here, I know this whole distance is 90. That must leave 50 here. If you did it purely mathematically, you could say 360 minus 310 equals 50 degrees. 240 is like right here. Once again, this is 30 degrees, so this is a 240 degree angle. Shortest angle back to the x-axis. In this case, it's a negative x-axis. I'm here at 180, 240. What's the difference here? 60 degrees. Now, reference angles are always positive numbers. They're never negative. All we care about is the actual angle distance, not really which direction. Let's do one of these negatives. Negative 239. Let's figure out where it is first. So negative 2, if I'm talking about negative angles, this is negative 180, negative 270. So negative 239, you know, halfway in between here, it's like negative 225. So negative 239 is maybe so from here to here, from negative 180 to negative 2, it's like negative 59 degrees. And this is actually my reference angle, which I just call 59 degrees. Let's just do this last one on negative 670. Well, what you have to do is all the way around negative degrees short. So I think it's probably about right there. And I know that's 50 degrees. Because all the way here would be 720, negative 720, but I'm actually at negative 670, so I stopped 50 degrees short, which means that's my reference angle. So let me check my answers, and those all look correct. All right, let's see what's next. All right, reference angles when you have radians. Same principle, except now we're looking at angles and radians. 5 pi over 4. Where's 5 pi over 4? 5 pi over 4 is 0. 5 pi over 4 is right here, halfway in between. So if we know from here to here is like pi over 2, we know halfway is pi over 4. If you ever want to do these mathematically, once you know where the angle is, you can say 5 pi over 4. So this reference angle is going to be 5 pi over 4 subtract pi, right? And if I get a common denominator, so some people, if you're good at just visualizing this, you can easily do it. If some people prefer math, you can do math, but really to do the math correctly, you have to sort of still have the picture in your head. 4 pi over 3 is actually right in here somewhere. Just for fun, let's do this mathematically. So to get this angle here, I have to take 4 pi over 3, subtract pi, because then when I do that, that would leave this angle here. 4 pi over 3 minus 3 pi over 3, pi over 3. I guess I should write it here. Negative 7 pi over 6. Negative pi is here. Negative 7 pi over 6. So you could think of this as negative 6 pi over 6, right? That's the same as negative pi. So this is negative 7 pi over 6. How much further did we go? Negative pi over 6, but of course reference angle is always positive. 13 pi over 4. So here's one where we actually go around the unit circle, because 2 pi equals 8 pi over 4. So 13 pi over 4 is really 2 pi plus 5 pi over 4. So 13 pi over 4 is really the same as 5 pi over 4. We actually just did 5 pi over 4. In fact, up here, I don't have to do it again. It's pi over 4. All right, let me check these again. Pi over 4, pi over 3, pi over 6, pi over 4. All right. What is the exact value? You know what these are? This is just knowing your unit circle. I pretty much got it memorized. Whether you're allowed to have the unit circle on your test or not, the whole key is 2 pi over 3 is right here. Since I know the sign, I'm looking for the value of y. I know it's square root of 3 over 2. Sine of 5 pi over 4, 5. So I'm going to label this. This is 2 pi over 3. 5 pi over 4 is the halfway. Sine negative square root 2 over 2. Because I know this point here is negative square root 2 over 2, comma negative square root 2 over 2, right? From the unit circle, I know the x and y of that point, and I know the y is going to be the sine. Let's see if there's some more of these. Oh, there are not. Let me check these now before I move on. Square root 3 over 2. Just out of interest, I looked at the answer. They called it negative 1 over square root of 2. These are actually the same. If you remember how to rationalize. If I want to try and get rid of that radical out of the bottom, I'd multiply top bottom by square root of 2 over 2. Square root of 2 times square root of 2 is 2. So these two are the same. And I think WebAssign will take either one of them. All right, next one, 22. Some more of these. So once again, I didn't say this last time, but when they say find the exact value, that means you're not going to go grab your calculator and try and punch in 225 degrees and hit your sine key. That would be incorrect. Exact value means use your unit circle. There's a chance you might have some square roots and stuff in your answer. It should not be a decimal answer. So let's go find 225 on the unit circle. Well, I know 180 degrees is here. 225 is 45 degrees more, so it's actually the halfway point in the third quadrant. The sign, I know this point here is negative square root of 2 over 2, negative square root of 2 over 2. The sign would be negative square root of 2 over 2. Sine of negative 300. So in terms of negative, this would be negative 270 up here. So I'm going 30 more to get to negative 300. So it's really this point right here. The sine, the value of y at this point up here, square root of 3 over 2. So those are all about just finding your angle on the unit circle and then finding the trig functions. And another one, cosine of pi over 4. Where's pi over 4? It's the middle one right here, right? Square root of 2 over 2, square root of 2 over 2, the value of x, square root of 2 over 2. Negative 5 pi over 3, so negative direction. Best thing to do is, if you know where positive 5 pi over 3 is, unit circle, positive 5 pi over 3 is right here. So whatever distance you go to get to positive, so I go through 3 quadrants and then pi over 3 more, I do the same thing except in the opposite direction. So I go through 3 quadrants and then go pi over 3 more. So that's negative 5 pi over 3, which is really the same as pi over 3. And what's the cosine of pi over 3? 1/2. All right, what's next? Wow, we got a bunch of these. We'll just keep doing it since they're pretty quick. Tangent of 405 pi. First thing I notice is this angle is more than one trip around the unit circle, right? So 0's here and also 360. So one trip around, and how much past 360 did I need to go? 45. So right here, it's 45 degrees, and it's also 45 degrees. So the tangent is the sine over the cosine. So at this point, the sine is square root of 2 over 2. Cosine is square root of 2 over 2. It's pretty clear, that's 1. Tangent negative 240. So going in a negative direction, I know this would be negative 180. This would be negative 270. I'm going to go 60 degrees past 180. This is actually the same with the positive 90 plus 30. This is the same as 120 degrees. It means I'm right here, this angle. And the tangent. So the sine of this one is square root of 3 over 2. The cosine is negative 1/2. So once again, the shortcut to simplify this is you take the bottom fraction and you multiply the top by the reciprocal. So hopefully, if I didn't mess up, it's negative square root of 3. Yeah. How many more of these do we have? Wow, we still have a couple more. This is probably the last one, because these pretty much all end up sort of being the same. I'll do one more radian one. Cosecant. All right. Well, that's good we're doing this. This is a little twist. So this is not sine, cosine, or tangent. So what do we do? What I'm going to do is Since I know cosecant and sine are reciprocals, let's just find the sine. Let's find the sine of -3 pi over 4. And then if I take the reciprocal, that'll be the cosecant, right? So I go ahead and I find the answer for its sort of partner. And then if I flip it, then that can be the actual answer. So let's find the sine of -3 pi over 4. So -3 pi over, if you need help, think of +3 pi over 4. Where's +3 pi over 4? It's 9, it's pi over 2 and then halfway through the next quadrant. So if you go in the negative direction, you need a circle. So it's right here. It's -3 pi over 4. What's the sine of that? This point right here, the sine, the value of y is -√2/2. So I flip that to get the cosecant. I know in the world of algebra, they used to make you get rid of that square root, but in the world of trig, which is nice, I don't really care. So I'm going to leave that as my answer. It should be okay. Cosecant 2 pi over 3, same thing. Let's go find the sine of 2 pi over 3. And then we'll flip it. 2 pi over 3 is right here. I know the sine is √3/2, which means the cosecant must be 2 over √3. I'll just check those. The answer it gives is -√2, but once again, if I rationalize this, I get -2 √2 over 2, which is that. So those are the same. So that is correct. And 2 over √3. All right, we're moving along. Let's actually do, since these are the oddball trig functions, I guess I'll do one more, because here you got a cosecant, or at least I'll do, well, let's just do these. Cosecant of 240. Once again, cosecant and sine are paired up, so I'm going to find the sine of 240. I know here's 180, here's 270. So you can think of either 60 degrees past the 180 or 30 degrees. So it's in here. It's on the unit circle. Looking for the sine. The sine at this point is the value of y, which is the √3/2. So if it's negative, therefore the cosecant is -2 over √3. -510. -510, one trip around is -360. And then I think I will need to go a -150 degrees more to get to -510. So -360, then here's 90, 60 more. I think that should be -510. So, you know, we got our 3 key points here. This one, what's the sine? This point here, the sine is -1/2 Therefore, the cosecant must be -2. And those are correct. All right. Maybe I'll do these last two. Just might as well finish them out. Cotangent of 120. What I'm going to do is I'm going to find the tangent. Or actually, since cotangent, do you realize cotangent, cosine over sine? So like always, there's two ways to do this problem. I could go find the tangent and then take the reciprocal with the cotangent. But I realize the cotangent is cosine over sine, right? Because tangent is sine over cosine. So if I flip the tangent, I get the cotangent. So I'll just do cosine over sine. Let me go find 120. So 90's here. 120. It's one of these special angles. This point here is x is 1/2, y is square root of 3 over 2. So x is like cosine, except it's negative over here. Y is like the sine, square root of 3 over 2. To simplify this, you flip the denominator and multiply. 2's cancel out. I think the answer should be -1 over square root of 3. Guess I could check that before I go on. And that is correct. Cotangent -150. Let's figure out where -150 is. So -90's here, and I'm going 60 degrees more. It looks like I'm right here. That looks like -150 degrees. That point there, so cotangent cosine the x of this point, which is negative square root of 3 over 2 over the y, which is -1/2. Negatives cancel out. By the time you do the math, should end up with square root of 3. All right, I think we're winding down. Trig graphs. I think the last major topic of all right, we'll see how many of these we have, how many we want to do. So here we go, trig graphs. Find the amplitude, the period, and the phase shift, and then later on, we have to try and choose which graph is correct. We'll go and graph it on our own, and then we'll hopefully see that they match up. Standard equation. It's always a place to start. A times the sine of bx plus c. To figure out amplitude, period, phase shift, we need to know what A, B, and C equal to. So A is 1. Looks like B is also 1. And C is pi over 4. Now A equals 1 is the amplitude. The period, which we call T, is 2 pi over B, since B is 1. Looks like the period's 2 pi. And the phase shift is negative C over B. Negative, so C is pi over 4. And B is 1. Looks like the phase shift is negative pi over 4. So let's go ahead, so negative pi over 4. I'm going to make sure about these before I start to graph it, just so I don't waste my time. I think they're correct, but yeah. So even though I could choose down here, I'm going to graph it myself. This is good practice. First of all, the amplitude is 1. My period's 2 pi. So then I chop in half, which is pi, chop in half again, which is pi over 2. And then in here is 3 pi over 2. Now I'm going to graph a standard sine wave with no phase shift. When the angle is 0, the sine is 0. So it starts down here. At pi over 2, it goes to 1. At pi, it's back to 0. 3 pi over 2, it's -1. And then back to 0. So here is the dotted line is the standard sine wave. However, I have a phase shift of -pi/4. So I have to take this whole sine wave and move it in the negative direction pi/4. Let's first figure out what distance pi/4 is. Well, here along my x-axis, this is 0, this is pi/2. Pi/4 would be right in here. So this is the distance I have to shift this whole graph to the left. So what I normally do is I take each point and I sort of do that. So here it goes to here. So I take sort of each main point and try and move it over the same amount. Then so that's what the graph should look like. So we can see if one of these graphs down here sort of looks like it. So it looks like it moves a little bit to the right, peaks out at pi/4. It's definitely not this one. Could be this one. Could be this one. Not this one. Looks like it's either one of these two. These are pretty. I'm trying to figure out what the difference is here is, because they look sort of identical. Let me look up my answer because it's not clear to me. Wow, very bad. I think this one here is that there's that pi/4, and this one is maybe more like pi/2. Very subtle, not very good. That's the actual answer. It should make it maybe a little more obvious than that. Anyway, all right, let's see if we got some more trig graphs. All right, same problem. This is a cosine, so we'll do this one. So once again, the standard equation. So this time A is 5, B is 1, C is pi/4. Therefore, the amplitude, which is A, is 5. The period, 2 pi over B, which is 2 pi over 1, which is 2 pi. Phase shift, negative C over B, negative pi over 4 over 1, negative pi over 4. This looks just like the problem we did, except it's cosine instead of sine. So now, once again, here amplitude is 5, so we make these 5 and -5. Period's 2 pi. half is pi, half of that's pi over 2. Now if I graph the standard cosine, when the angle is 0, the cosine is 1, so it's up here. Then it goes to 0, -1, 0. So there's the standard cosine. However, it's going to be shifted to the left, pi over 4, which is about this distance here. So the actual graph is now we'll see how close. I think this one's better because this looks like it could be the correct one. That's obviously not. This one's not. This one's not. So this one's a more clear cut. Hopefully that should be the correct one. So let me just check. Yep. All right, let's see what else would be helpful to do. Maybe we'll go through this real quick. It's really nothing. Looks like A is 1, B is 1/2, C is negative pi over 4. Amplitude is going to be 1. Period is 2 pi over B. 2 pi over 1/2. Flip that, so it's really 4 pi. Phase shift, negative, and C is negative pi over 4, and B is 1/2. So the negatives cancel out. This becomes 2 over 1. Phase shift should be pi over 2. So since period's 4 pi, half of it's 2 pi, cut it again, you get pi, and this is 3 pi. Amplitude's 1. Standard sine wave starts low, goes high, low, high, middle, low, back to 0. Now I have to shift this pi over 2 to the right. Pi over 2 is this distance here. There's pi over 2. So this goes right here. This one goes right here. This one goes here. This one goes here. This one goes here. So which one of these look like this? I guess the key is maybe this goes through right here at pi over 2. Could be that one. Not that one, not that one. So it could be these two. Oh, here the amplitude is 2 and -2. It's got to be this one. All right, last couple problems. Now they sort of flip it where they give you a graph. They give you the graph, and then they want you to figure out the amplitude, period, phase shift, and then eventually they want you to write the equation of that function. So do the opposite. Start with the graph and come up with the equation. Now for these problems, you'll notice that they do it because the key is they have to really tell you whether they want the equation as a sine or a cosine function. So here they tell us it's a sine function. So the standard equation is our a times sine and in parentheses bx plus c. So basically we have to figure out a, b, and c. Once we figure out what those are, we've got the equation. And we're going to figure out a, b, and c from the amplitude, the period, and the phase shift. So the amplitude, period, and the phase shift, we should be able to figure out from looking at the graph. Amplitude is always pretty straightforward, right? Looks like this thing goes from -4 to 4. Therefore, the amplitude is 4, which means A is 4, right? The amplitude is always A. So now I can say A times the sine. Now the period is how far you have to go before the graph begins to repeat. So if I go here, I'm on the downward slope. Let's look at here. Downward slope in the middle. Downward slope in the middle. How far did I go? 4 pi. So it's like the period is 4 pi. But knowing the period is 4 pi allows us to calculate b, because you know the period is 2 pi over b. So if the period is 4 pi, we have 2 pi over b equals 4 pi. So if I move things around some, end up with b equals 2 pi over 4 pi, which is 1/2. So all I need to know is c. And c I'm going to maybe figure out from the phase shift. Phase shift is always a tricky part. What you have to do is, and here they do this crazy thing where on these problems they always want the phase shift. They want you to, you can have a choice whether you phase shift to the left or to the right. They want us to always go to the left. So the phase shift is going to be negative. But anyways, what you have to do is I have to go up here and I have to compare my graph to a standard sine graph. In other words, a standard sine starts low. It would start low, go high, back to the middle, go low, back to the middle. So there's the standard sine wave. Now the question is, how far do I have to go to the left to get from the standard sine wave to mine? So this right here looks like it's at negative pi. This here is at pi. Looks like I had to move negative 2 pi for a phase shift. And we know that phase shift is negative c over b. So negative c, I know b is 1/2, and the phase shift is negative 2 pi. I can actually multiply both sides by 1/2. The negatives cancel. Looks like c is going to be pi. So I hope that's the equation. Amplitude 4, period 4 pi, phase shift negative 2 pi, so 4 sine 1/2 x plus pi. Great. Like we have one more where they give us a graph. Sine function. Would have been nice to do a cosine, but anyways. Amplitude obviously is 5, so A is 5. Period from here to here is pi. Looks like B, I believe, is going to be 2. And then phase shift. This is a sine. The sine starts low. Up, down, low, back. So what tricky thing is, they always want you to go to the left. It's almost like I have to go okay, it's actually not too bad. It's from here to here. That's probably pi over 4. Looks like the phase shift is negative pi over 4, which means phase shift equals negative C over B. Negative pi over 4 equals negative C, and B is 2. So it's both positive. It looks like C is going to be pi over 2. We'll see if that's correct. 5 pi negative pi over 4. Yep. All right, that's good. Last problem, one story problem. Up, it's on here. Oh, here at the very bottom. Pilot flying altitude of 5,000 feet wishes to approach the numbers on a runway at an angle 11 degrees, approximate to the nearest 100 feet, the distance from the airplane to the numbers. So story problems, usually the hardest thing is to figure out so if this is the ground, and we're going to say the numbers on the ground start right here. And here's this airplane. And he is currently $5,000 feet in the air. There's the tricky part. He wants to approach the runway or these numbers at an angle of 11 degrees. What that means is, it's like he wants to come in a straight line. So it's almost like we've created a right triangle where this distance here is 5,000. Here's an angle. And we want to figure out how far he has to actually fly before he gets to the ground. So we're trying to find the hypotenuse. We know the opposite and the angle. Looks like it's a sine problem, right? because the sine of 110 degrees. So, right, so katoa so would be 5,000 over x. If we solve for x, x would be 5,000 feet over the sine 110 degrees. Now this is one where you do have to use your calculator. Make sure your calculator's in the degree mode. So 1/110, the sine, stick at the bottom of a fraction, times 5,000. Then write down the answer, and then we'll figure out what answer they're asking for. 5320.8. Now they say approximate to the nearest 100 feet, which I think means this is the ones, the tens, the hundreds. So I think they want us to round to here. So I think it's going to be 5,300 feet, if I don't mess up. And it looks like I did. Oh, I think I put, hang on a second. Fly altitude 5,000 feet. Angle of 11 degrees. Oh, when I put, I think I, wow. I had my degree sign here. Wow. That was bad. It's supposed to be 11 degrees. Wow. You guys probably all saw that. Sorry about that. Let's take the sine of 11 degrees times. All right, so now we're going to get 2604.2. If they want it to go to the 100 feet, I think it's just 26,200 feet. And that is correct. All right, so there you go. Those are the kinds of problems you'll probably see on the test. So work through those and you'll be in good shape.